All right. Hello, everyone. Welcome. So glad you can join here today. If you are on this call, you are here for the Voxel 51 webinar on annotation pipelines, really kind of an end-to-end feedback annotation focused workshop and best practices using the 51 platform. So happy to have you here. My name is Nick Lotz. I work with the community team here at Voxel 51. And welcome again. Over the next hour or so, we are going to do a workshop on building, as the title suggests, feedback-driven annotation pipelines. Really, the golden focus of this workshop is thinking about how we can have an extremely tight curate, annotate, train, and evaluate loop with our visual AI models using FiftyOne and FiftyOne's in-app annotation capabilities. Whether you are brand new to the FiftyOne platform or whether you've been using it for a while, this will have something for you. We have just released in-app capabilities on the platform, or in-app annotation capabilities on the platform. And we'll be taking a good look at that today in context with the rest of the platforms and FiftyOne's capabilities. So again, my name's Nick. We'll be here together over the next hour. Couple bits of logistical items. Again, thanks so much for those who have attended. If and when you have any questions, we will have definitely Q&A available here at the end of the call. At the same time, there is a Q&A panel in your Zoom toolbar. Sometimes you need to click the little three dots that say more when you hover over the toolbar, and then you can click Q&A. I'll be keeping a look at that as questions come in. If they're relevant in real time, I'll do my best to get to them in real time. At the same time, as they come up maybe towards the end of the talk, there'll be some Q&A time here at the end as well. From an assets and kind of takeaway resources perspective, there are a couple things that I will leave you with. I'll introduce them early in this workshop. Much of this workshop is built around a end-to-end tutorial we wrote that's available in the FiftyOne documentation. So the tutorial walks through using a multimodal data set not only to curate and annotate data, but also go through a training and evaluation, an iterative training and evaluation loop. We take a kind of test set strategy to make sure we're constantly incrementally improving the data that we're labeling and obviously improving the models in the process. We take an algorithmic, both actually a qualitative and quantitative approach to data selection. So we'll take an embeddings-based flow to try and uncover data that is both diverse and also data that is causing potentially models to fail. And we'll try to ensure that we're being as efficient as possible in our data selection strategies. And then we'll also take a quantitative approach as well. We'll look at what's called core set selection, which is a way of, again, looking at the diversity space of your data and choosing the most unique samples that are most worth labeling. And again, we'll kind of keep that tight flow in the process. All these resources will be available as follow-ups after this web workshop as well. The slide deck, the tutorial, the recording will all be available after this as well in a follow-up email. So if you've registered, you'll get all these as a follow-up as well. Okay. So let's take a look at where we are going. We're going to hop right into things here, and let's take a look at the problem space. So ultimately, the initial problem we'll be looking at is why annotation workflows based break down in the first place. Visual AI is critical in the sense that it relies on ground truth. It is not self-selective and self-labeled, to kind of use a less technical term, in the way that things like large language models or text-based models are, right? We have to tell the model what is the correct data that we are labeling. Couple problems with that. One is historically it's very labor intensive. Foundation models have helped, vision language models have helped, but at the same time, again, it's expensive and ideally, as data sets grow larger and larger and larger, they're they live in data lakes and so forth. We want to make sure that we are choosing the best samples possible to label and that it's continuing the process. Anyone who's built models before know that it's extremely iterative in the sense that you're pushing the boundary slightly further with each iterative training loop. Training a one-shot model through a kind of single linear path is not normally going to get you the best performance. It's a method of continuous improvement. So we're going to look at that loop and see what feedback-driven annotation looks like, kind of without burying the lead. It'll look at seeing, okay, where is the most diversity in our unlabeled data and focus that for labeling. And second is which type of data is causing model failures. Of particular interest are false negatives because those are famously difficult to identify using quantitative measures. There's some good qualitative measures, and that'll be a big focus of what we do here. And we're going to specifically focus on multimodal data. So we are going to take advantage of FiftyOne's group data set model to see when we have a collection of maybe different camera angles along with 3D point clouds that are associated together in what we call group samples, how can we ensure that we're building an effective loop? And then lastly, we'll end on architecture patterns. And again, there'll be kind of a demo interlaced throughout this as well, where I'll be looking at some of the highlights of the tutorial that I've linked and kind of doing a walkthrough of some of the main elements of that getting started guide, which again is really meant to be kind of an E to E flow of curate, annotate, train, evaluate within the FiftyOne app. If you want to kind of get a sense of where we're going, and if you even want to get started, this tutorial is linked here at the bottom. That takes you to this page, this annotation getting started guide. There are kind of two tracks to this tutorial. There's like a quick start where it just gives you the down and dirty of in-app annotation. And then there's the fuller track that goes through that whole, again, curate, annotate, train, evaluate flow. So if you were to go to this guide, again, just docs.voxel51.com/getting started/annotation. There is also a QR code that is at the end of the slides. At the end is a takeaway. I'll share that then. Again, you have a couple tracks. The quick starts track is really focused, again, on installing FiftyOne, loading a data set, loading a multimodal data set, getting started with annotation. And then the remaining steps, again, are very focused on that broader flow that I talked about earlier. And then again, we'll end with some Q&A as well. So let's talk about the annotation problem. So we are biased here at Voxel 51 towards data-centric AI, where our premise that we'd argue has largely been seen to be correct is that tweaking model architecture these days has less than an impact than ensuring that we're training our models on good data. At the same time, a purely spray and pray approach to the historically very manual and intensive effort of data annotation doesn't necessarily improve your model, right? Part of it is issues with data selection, right? So if we think about like classic example of like self-driving data, if our model fails at night, but two-thirds of our data set is during the day, and therefore two-thirds of our labeling efforts are on daytime samples, well, that's not what's causing our model to fail in the first place. What matters is selecting the data to label and label correctly insofar that it improves model performance without overfitting. What often goes wrong is that annotation lives outside the machine learning workflow. It often relies on outside vendors a lot of the time, whereas again, even though again, foundation models and internal tooling is progressively improving that, there often isn't feedback from evaluation to relabeling. Often the communication loop between, okay, here's our model evaluation metrics, precision, recall, F1, mean average precision. How does that actually map back to improving our data selection and our annotation? And then also models need specific data to fix specific errors. That often requires expertise that, again, an approach of simply as labeling as much as possible at best, incidentally, can get resolution on, but ultimately, when you have models failing for a specific reason, the best way to fix it is actually fixing the specific data that is that failure mode in the first place. So there's a couple ways we can approach this. There's the front end where data curation becomes increasingly important. That is, when we have massive and massive amounts of data that we have access to, labeling all of it 100% just simply isn't possible. So a key engineering problem on the front end is curating that data into a subset that'll give us a really good initial shot of a high performing model at the beginning and then iterating on that. Once we have that subset of data, more on those selection techniques in a little bit, what we can then look at is then how do we then go back and improve upon that subset? How can we choose additional samples to label based off our current state of one, what is our current diversity in our data set with respect to what we would want in real world conditions? And number two, what is the current failure modes of the model? Where is the model finding false positives? In my view, more importantly, where is the model finding false negatives? Where are we finding confusion, where there's class confusion between certain objects or whatever type of um, uh, labeling that we're doing on our data set? So curation and then iteration. And as I mentioned before, so much of this comes from a garbage in, garbage out problem. When you don't have a good strategy for data curation, often the result is misleading metrics and then poor generalization in production. When your model's not trained over on ultimately a correct data set that moves performance, the result is poor performing models in real life. The result is missed edge cases because the model was never appropriately trained on that in the first place. And then there's also the idea of silent degradation. And this part is critical, where ground truth is our kind of first principles. What is the correct identification of cars, of people, or whatever objects we want to identify in our data set? Incorrect labels silently degrade model performance because we are operating on the assumption that the ground truth is correct. You have to. Um, However, we therefore need strategies to go back and check to see, okay, does the ground truth actually have problems such that we need to iterate on our labels? And that's largely where a really tight loop of in-app annotation can come in, where you don't have to, export to an external service so that you can, more quickly iterate in real time within the platform in which you're curating, training, and evaluating. So again, the shift, to not put a too fine a point on it, is curation before annotation. So the traditional route is you might label everything, perform a whole bunch of annotation, then train on the model, and then QA kind of might be an afterthought in the sense that um, it's difficult to kind of reverse the loop and go back into annotation when you don't actually know what in the data is causing your model to fail. So there's a little bit of hoping for the best, and that's what this bottom left graphic is showing. Right, you have a pool of unlabeled data. You label everything. You train the model, and then maybe more of your effort in this case would be on the model architecture side because that's what you have control over. What we want to take is more of a feedback-driven approach. We can use curation techniques like embeddings and then what we'll call Z-score or zero-shot core set selection to find the highest value samples that are worth annotating and then train the model based off those samples. The idea here is that we are using very objective criteria to determine what data is likely to have the most generalizable model on the front end. And then we evaluate and find where is our model failing. And then from there, repeat the loop, right? If we can identify the parts of the embedding space that our model is not performing well on, we can redo the flow, identify additional samples, and either qualitatively by just examining the embedding space visually, or by performing methods like core set selection that we'll talk about, and then choose additional high value labels for re-annotation. And the idea is we're having a very metrics driven approach for continuous model improvement. So the new way, rather than just grabbing random samples, is to compute embeddings first. So we can have both a qualitative and quantitative understanding of our data, visualize the distribution, and then select what to label. So part of using using FiftyOne, which we'll look at in a little bit, is before we've even applied a label in the first place, we'll take our unlabeled pool of data and compute visual embeddings and try to find things like outliers or representative segments of the embedding space that we know we want captured in our initial data set. A technique that I'll show is by applying course set selection on top of that, we can color the embedding space uh, by by what we call the Z core. That is, which basically is a uniqueness value that allows us to see which parts of the embedding space are most worth our attention in generating an initial set of samples to label. So a question just came into chat: do we apply statistical approaches for selecting high value data? Yes, that will be the case. It's algorithmic, but I'll show you here in a little bit how we can apply both not just the embeddings computation and visualization, but also core set selection to actually color this space and kind of, it's not heat maps, but there's kind of a color gradient we'll see that allows us to point out, okay, here are unique values with high diversity, here are values with high diversity. We can select those and then curate a subset from there. And to that point, this is borne out in research. So we found here at Voxel 51, our machine learning team has found that smart selection almost always, or actually for many tasks, beats random sampling. So an example would be, let's say you have a data set, it's 90% daytime, 10% nighttime. Well, random sampling naturally would give you 9 out of 10 samples being daytime samples. But if nighttime is where a model's failing, random sampling is not the most efficient approach because random sampling reflects frequency and not diversity. So the rare but critical cases go underrepresented. So it might not even just be nighttime samples, it might be samples of pedestrians walking alone at night. So we can use course set selection to add unique coverage. So if we have redundant data samples, those will score low, whereas more sparse regions will score high, so we can get a more representative data set. And one result, you can read the full paper for details. It's linked in kind of the in the annotation blog post that I'll share in a little bit. But using the kind of classic ImageNet data set, 10% of that, labeling just 10% of that data on the initial iteration of a model gave resulted in 54% accuracy for that model, outperforming 100% label-based methods of 100% of data. So there, we found that downstream models perform as good, or if not better, in certain cases than full data labeling through this course set selection practice. So what does that mean in practice? What would it actually look like in our workflow? So during annotation, the idea is have focused batches. So label, say, 50 curated samples, not 10,000 random ones. And again, the idea here is, these are kind of round numbers, but this will be an iterative process where we'll be continually adding additional samples that are worth labeling. In addition, is enforce your schema heavily. So for example, make sure that when you are using an annotation platform, like we'll see in FiftyOne in just a little while, ensure that you are subjecting your annotators to only using the schemas that you allow. So make sure that you're rejecting if, vehicle is attempted to be hard-coded when your schema only supports truck as, a bounding box that you can draw around an object. In addition, you need to make sure that your samples are aligned. And this is something FiftyOne natively supports through what's called grouped datasets. So when you're thinking about, say, the equipment on a self-driving car, you have multiple camera angles, and then you might have LiDAR, which would be like a 3D cuboids and a point cloud type sample. You need to make sure that those are aligned together within a single sample, so that everything from time series to model recognition is again aligned within a single view. And then when it comes to then training, the way our tutorial is going to approach things is you might start off with a very small sample set. Again, 20 is just kind of an example I do here. It would likely be larger because again, if we use algorithmic methods, it's pretty quick to identify the samples needing labeling. But the idea is we have, a certain subset of samples with expert verified labels. There's a hopefully automated schema check. So again, we're enforcing the schema, but we perform quality assurance on it as well. And then in addition, before training, a coverage check to sanity check things like making sure that, okay, if samples have 0 labels on them at all, catch this before, it corrupts the training pipeline. And so that's part one. Now, remember I said there are 2 key parts to this data-centric approach. Part one is curating a diverse data set where underrepresented regions are represented, even though they're underrepresented in your total data set, they become a critical part of the subset. And then the second is using your model as your debugging tool in an iterative approach. So train the model based off your initial selection and then listen to what it tells you. So false positives will obviously reveal label noise or ambiguous cases. Those are fairly easy to identify. What is more intriguing is false negatives because those expose gaps in your training distribution. They're also kind of the unknown unknowns of the process. They are difficult to identify in practice. This is where embeddings can help. So when you look at the model false negatives relative to ground truth in your test set, you can look at the embeddings distribution and see, okay, where is the cluster in which the model is actually failing? And then the last piece is obviously your confusion matrices. Where does your schema need refinement because the model is confusing one object for another? Again, that's a native part of the FiftyOne platform as well here, as we'll see in just a minute. So again, this is going to be one of several iterative loops. This becomes a feedback signal for your next labeling batch, where from here you'll choose based off a combination of what is still underrepresented in the data set and where is the model failing. You'll then choose your next batch. So what's a good balance here? There is no universal answer. It is well established in the literature that you need to balance coverage and targeting. One approach is about 30% for coverage and about 70% for targeting. Naturally, this would be a little iterative because you'll adapt this based on how your model is performing and where you're finding influence on one side or another. So when I say coverage, I'm talking about diversity. And this is where that analysis of the embedding space and core set selection will come in. This will be ensuring that we have a balanced distribution of data to prevent and as well as preventing model overfitting. And then the other two-thirds-ish is targeting, where we're actually mining samples similar to your failures so that we can improve the model on the specific errors your model is making. Like again, maybe the model can't identify stop signs in the snow, right? The idea is, okay, well, we need examples of that to specifically tell the model this is what a stop sign looks like when it's covered with snow. So again, round numbers in a budget of 100 labels per iteration. We might see 30 samples where we're covering new regions of the embedding space, and then maybe 70 samples from failure mining, again, where we're finding clusters of either false positives or we're finding more intriguingly false negatives. So closing the loop, we're looking for an approach that looks something similar to this. So from a cold start, our initial selection, we don't have a model yet, right? So we can't do targeting at the beginning. We have to focus entirely on coverage. So we're focusing purely on embeddings and other algorithmic techniques to ensuring that we have a diverse subset of data so we can get a baseline model with broad coverage. And then as we continue to iterate, we're going to still focus on coverage, but then increasingly focused on model targeting. And as we add additional samples to our data set, we're kind of approaching, not sometimes asymptotically approaching that 70-30 split that I talked about, where 30% is based on coverage, 70% is based off targeting failure modes in our model. So we can rapidly improve based, again, on model failure modes. And then again, as we do later iterations, we're going to focus on, okay, when are we starting to plateau? When are we starting to reach diminishing returns? And then we have kind of additional, approaches from there where we might need to focus on model architecture. We might need to focus on our total pool of data that we've been sampling from and continuing to improve that. We might start to approach different modalities again. Because this exact progression I'm talking about, on its own can only last so long. But we've seen good results with core set selection. All right. So I'm going to drop into kind of a screen share demo here in just a moment. But before I do so, just a couple things to keep in mind. This is very conceptual. When it comes to doing this in practice, couple points here. So first of all, maintaining a frozen test set is critical, right? So there are opportunities in FiftyOne to have different views, clones of data sets, and ensure that one set isn't leaking into the other. That's obviously critical here because then you can't trust your model otherwise. Tracking what's labeled, QA'd, and ready for training can be done through tagging methods, saved and shareable view methods. Measuring efficiency can be useful. That is, what is the number of labels in our samples per change in mean average precision. This should be taken a little bit with a grain of salt, especially if you're using model-assisted approaches to labeling, because at that point, labeling becomes a little bit less of a tedious, expensive exercise when you start using foundation models increasingly, but it can still be useful, again, especially at the beginning. And then what's also useful is being able to annotate without leaving the curation environment, right? So 51, particularly the enterprise version of 51, includes quite a lot of capabilities when it comes to dataset versioning, access control, exportable data sets within the app. Having a similar flow where you don't have to leave the app and you can kind of measure your data set versions and the progress on them from both an annotation perspective and a training evaluation perspective within a single commit, so to speak, of your data set is ideal. So you don't have to kind of like, be on a swivel back and forth between the state of your annotation platform and the state of your training and evaluation loop. So there's quite a few primitives that we'll show here in just a moment. So what does this look like? This next demo is going to be adapted heavily based off of the tutorial that I linked earlier. And again, can be found here at docs.fox51.com under the Getting Started guides. It's this annotation guide here. For those that want to follow along or ultimately go through this tutorial, right here is the code that you'll also find at the beginning of the tutorial to get started quickly. Everything I'm going to show is available in this flow is available in the open source version of 51. It's an installable Python library, literally just pip install 51. It includes a local web server to serve the UI. It includes also a built-in MongoDB database that'll just be hosted locally as well. And then 51 also includes a dataset zoo of easily importable datasets to get started. So there's literally a method you can run, load zoo dataset. You can find all the different zoo datasets we support kind of natively importable from the zoo in the docs. But the one we're going to use to get started is this kind of cryptically named Quick Start Groups dataset. What this actually is, it is a subset of the KITTI, multimodal self-driving data set. So this subset of it includes, it's not huge, it's about 200 samples, but it's useful for demonstration purposes of left camera views, right camera views, and 3D point clouds. And again, I'll swap over here in just a moment as well. So when you pip install 51 and you load the data set, what does it actually look like? Well, give me a moment here. It looks something like this. So the 51 app launched. Here is the server. We are pretending that this is let me actually do something, just pretend here for a moment. I'll switch to another data set here and kind of iteration of this in a moment. Here is what it looks like in the UI. You can switch left view, right camera view is like kind of what you're seeing in the sample grid. You can view point clouds in the sample grid. But if I click into a particular sample and I open it up here, here is like the full distribution. Couple things to note. Again, notice in this grouped data set modality, we see, whoops, sorry, give me one second here. Got it, there we go. We see the full point cloud view. We see cuboids aligned with bounding boxes on both the left camera and right camera views. These are all mapped through a sample ID and mapped in this time series data as well. So this is kind of the explore pane. What you'll also notice here as of last Thursday, when 51 when 1.13 of 51 was released, is this annotate tab. So we can see in this annotate tab, this is where the annotation loop will come in, where I have my schema that I can either modify through either this graphical interface, or if you've used the 51 SDK before, here's the JSON schema that you can update as well. And then within here, I can choose to say add a new bounding box. Maybe I want to tag a car. Let me do that here. There's my car. And now that becomes literally just a new label that is added to the data set. Right now, we support classification and detection labels for both 2D and 3D. So if I were to go to the, oops, sorry, let me go back here for a moment. Let me change the annotation slice to PCD. Let me find a car here. On a similar front, if I were to find my schema here and I were to add a cuboid, let's see where are we at here, car. Imperfect example with this initial drawing. But here we can see I've labeled this car here. And then you can just as easily drag and edit existing boxes as well. So in-app annotation is now, again, fully built into 5051. Where this becomes most powerful is when this becomes a QA method with the larger loop that I discussed earlier. So what I'm going to do now is I am going to go to a copy of this data set that I've kind of set up as, oh, actually, nope, it's right here, that I've kind of set up into different views to kind of work our way through the um, flow that I discussed earlier. So where we are going to start is, let's say that I have a raw unlabeled pool. So again, I'm using a round number here. Let's say my pool of data is 130 samples. Now, where did I get this from in the first place? So a couple useful things that 51 has. Even starting here, this might be drawn from an even larger superset of data, like say a data lake. 51 includes some pretty powerful integration with those sorts of features like your data warehouse or your data lake, Databricks, BigQuery, Snowflake, where, for example, if in this data set here, we have a feature called Data Lens, where before I even have this initial like pool of samples, I can open this data lens feature. And if I have things like vector embeddings configured in my data lake, I can search for samples that I want to add to like my initial kind of superset pool of data that I will then subset from there. So maybe I have like pedestrians walking at night. I might search the vector. Maybe if I have like, natural language search here, I can search the space, and I am querying my broader data lake in natural language for these samples. So this will take just a moment, and I'm not going to go through the whole thing here, but you see the idea. Now these are labeled, right? So these are labeled samples. But even if this was an unlabeled pool, it's not using these labels to find them. It's using natural language search, and I could import these in. But let's say I have this pool. Um, Number two is, how do I select from there? Well, the most powerful way is to compute embeddings. So if you were to go into the, let me pull this up real quick. And just to save a little time, if you were to go into the tutorial, give me one moment here. Sorry, I was grabbing the right step. This is step 3 of the tutorial. You can run some code to compute embeddings on different slices of data. And this is a native method in 51. You can compute the embeddings themselves and then compute the visualization based off the embeddings. And then optionally, so that'll give you a really good visual of your embedding space. And then optionally, you can also run zero-shot coarse set selection as well. Again, linked here in step 3 of the tutorial, where it basically it gives a uniqueness score to each sample in the data set. So what you end up with is something that looks like this. So here is my raw embedding space. Again, just 130 samples, but we can kind of extrapolate from here. And then also useful is if I then color by z-score, the more into the green and yellow we are, the more unique the data and the more interesting it would be to add to our subset of our initial training data. So for example, we can see kind of around here is probably worth taking a snag at. Here, it's worth snagging maybe a little bit up here. Again, 130 samples, so not a huge embedding space. Again, the larger the data set, we could potentially see other areas that are worth selecting. And from there, that can be your initial subset. So we might then pretend that we select maybe from here, and then maybe some additional areas, and then we save that into a view that maybe we're calling our initial subset. We might call it batch V0. And this batch V0, we can see again, small example, there's 37 samples here. So, a small subset of the total 130 samples, and it's been grabbed from this area of the embedding space. And again, the idea here is this is unlabeled data. This is not a huge lift potentially for our annotators to go through. FiftyOne will always support exporting to particularly open source annotation tools like CVAT and others. We have very deep integration with third-party annotation tools, but now the platform itself includes, whoops, if I open up a sample, the ability to annotate these directly as well, define a schema, and have it all done in app. So I could easily do that here. All right. So this becomes our initial batch. And then it's from here that we can train our first model. Again, for the sake of time, I'm not going to go through the whole model, initial model training loop here. Note that this is also well supported in FiftyOne. If I go to the next step in the tutorial, actually to step 5, so step 4 here is annotation QA. You can again create cuboids and 3D annotations in the app as well. What you can then do is then you can train your first model. The tutorial example has this fine-tuning a YOLO V8 model, and then from there, we can say that, okay, now we have, let me go back, oh, sorry, let me go back to here, a view where we might call this our evaluation set. Maybe it has 30 samples where we see there are now predictions on it. And this is our first pass, right? It's kind of hard to see these. These are in gray here, but these are predictions that are overlaid with the ground truth. Good question here in the chat. Does Z-core work it's not the exact same algorithm as FiftyOne's compute uniqueness function. It is another uniqueness related method. I would need to direct you to the actual paper for the deep details on how it works. The GitHub, it's not the GitHub repo, but the blog I'll share as a resource here in a bit, links to the blog that's focused on Z-core. It is not exactly the same as the way the k nearest neighbor of the compute uniqueness function works. That there are some differences, but it is related. Compute uniqueness is still very powerful as well. It allows you to sort your data by uniqueness, find the most unique samples for later labeling. Zero-shot core set selection is slightly different, but related. Okay, so now I have this validation set. We have predictions overlaid. Let me go to explore here. Sorry, let me go back here for a moment. Here's left. For some reason, this is showing the PCD. Give me 1 second. That's why. And this is still showing the PCD. I don't know why. Give me one last refresh here. Type error, failed to fetch. What's going on? This site can't be reached. Great. 1 second. I think my localhost connection just died here. I can flip over to another one here in just a moment and show you another example while we're waiting. In fact, while that is happening, while I'm relaunching the FiftyOne app, which again, I think there's some gremlins in the demo system. Real quick, while I'm back here for a moment, just like a quick interlude. Remember I mentioned that human annotation is obviously critical. We are definitely going to need to rely on experts to annotate data. At the same time, foundation models are increasingly supported as well. FiftyOne does include auto labeling via foundation models as a native function in FiftyOne Enterprise. The reason it is in enterprise and not natively in open source is that it does require what's called delegated operations, which are ways of delegating work to attached GPUs. But the way that works, but the way it works in practice in your flow is you can obviously open up a sample, annotate it manually, but also on top of that, you can go to this auto labeling panel and choose a target set of samples, what type of of what type of labeling you want to perform, a foundation model to do the labeling, the classes you want to label in your data set, the minimum confidence threshold. And again, within the app, you can apply your labels there as well. So again, when I say that we're performing an annotation loop, I really mean human in the loop annotation with potential varying levels of automation. Okay, let me see if I can reconnect to my system here. All right. I think there was another question saying, when do you expect to support segmentation and when do you intend to support segmentation masks within the built-in annotation? So segmentation is supported within auto labeling in terms of the in-app label editor. It is a roadmap item. It is something we eventually intend to support. Right now, brand new, it is classification and object detection, but segmentation is definitely on the roadmap. I don't have a firm date at this time, but it is definitely something we're developing and prioritizing. All right. So looking at this validation set, we can see, okay, we've applied predictions and ground truth. From here, we now want to get our initial set of model metrics, right? This is our first iteration here. So we might go in, depending on which version of FiftyOne you're using. If you're using the enterprise version, there's a built-in in-app method of performing model evaluation. If you're in open source FiftyOne, there's an SDK method, just like everything else shown here, where you literally just run evaluate detections or a similar method, depending if you're doing classifications, detections, and it computes critical model metrics with respect to your ground truth. Now, again, in our case, this was a sample set of 130 samples of a particular slice in our case. And I fine-tuned a YOLO model on commodity hardware. So I would not expect in this first iteration that the model would be, super high performing. But if I look at my initial metrics, the answer is correct. It is not super high performing whatsoever. At the same time, we can start to get some initial senses of where is the model performing, where is their class confusion. And I would particularly suggest that false negatives and class confusion is where you'd want to start. And this is where we can then begin to approach our 30-70 split of from here on out, let's try to approach 30-70 of, okay, looking at the embedding space. So let me go back. So maybe we can find a lot of instances where, let's see, there's false negatives or false positives on certain things. So I might go into the embedding space and say, okay, where are nighttime or pedestrian samples clustered and try to see if there's false negatives. So I might go back here. Rather than coloring by course slots, let me actually go back to my pool. Rather than coloring by course shot selection, I might color by, oh, you know what? I would need to add the ground truth label to my embeddings computation. I didn't do that here. but similar idea. I apologize. You actually do this in the tutorial. I just didn't do it here, but it would highlight by class, and then you might start to select clusters and then choose additional samples from there. And then it just becomes an iterative loop, right? So you have your pool, you might augment that pool further from a data lake using a tool like Data Lens, and then go through the loop of annotate a few key samples, train a model based off those annotated samples, run model evaluation metrics, find where your model is performing poorly in terms of core statistics or class confusion, and then again, take an approach of, okay, where are the types of samples where the model isn't performing well? Again, highlight those in the embedding space and then tag them for your next batch. And then go from there. So where ultimately does this take us? Well, it takes us into a couple places. So let me quickly go back to my slide deck here. First, we need to take note of a couple failure modes, right? One thing that I kind of took for granted is that our training and test sets are properly segregated, right? You need a frozen test set. Otherwise, you can't trust any of the work that you're doing. The second is be very, very careful about label drift over time. Gatekeep your schema heavily. Make sure that labelers aren't adding, again, new labels that weren't originally addressed by the model. Make sure you include a golden set of data that you know is 100% correct in its ground truth. Don't chase only edge cases, right? That can result in some cases in model overfitting towards those edge cases that divided approach of maybe a third-ish towards coverage, two-thirds-ish towards model failure modes is important. Again, when you have that tight loop, you can kind of easily kind of make sure you approach that ideal of whatever you choose. And then again, from a QA bottleneck standpoint, anyone who writes software or trains models knows that eventually you need to ship. Often you need to ship fast. You always need to iterate. Creating focused views in FiftyOne, in-app annotation fixes like we now support is the way to go here. Because again, very often exporting to a third-party annotation tool requires an entire different pipeline. Here we can keep everything compact within the platform. So before I move forward here, a couple questions, or I guess another question here I see in chat. What type of multimodal data can Voxel work with? How to best annotate that? For example, 3D molecule data, description, pictures. Yeah, so from a general data support perspective, FiftyOne supports obviously 2D images, LiDAR data, 3D point cloud data of any type. And we support annotation of 2D and 3D data. So classification, detection, cuboids. That's kind of our initial pass of supporting annotation. The goal is to very, very quickly increase the annotation support. From a general data support, so curation, embeddings, training models, pretty much virtually any type of 2D and 3D data. We also support video as well as video frames, naturally, because we support 2D images. We also support audio and audio spectrograms, and we're steadily increasing kind of our coverage of what we support there as well. Right now, what's supported in-app annotation is currently a subset of the total types of data modalities FiftyOne supports, but our plan is very much to have that subset of annotation supported modalities like reach the total superset of modalities we support across all parts of the app. All right. So what are a couple key takeaways? I mentioned this already, and then I'll kind of leave us with kind of a couple lessons learned and then where to go from here. Like I said before, everything I've discussed is available within the open source app with the exception of the auto labeling panel that I briefly opened. And then also technically the data lens panel is something that is enterprise only as well, but definitely curate, annotate, model training, model evaluation is all supported natively. Really, I'd say if there's one thing that is most critical of everything I discussed, aside from the in-app annotation, is the embeddings engine, right? Using embeddings is critical for again, having a quantitative and then qualitative visualization of the embedding space where you can just have a bird's eye view of your data distribution, and then using zero shot course set selection to actually color the embedding space of high value samples. Now, it's worth noting that Z-core is really just it's a mathematical algorithm. So this GitHub repo in the Voxel 51 org is a useful way to get started. And then the tutorial actually has you run course set selection on the data within 51. But right now, it's not just a button that you press. It is a method, an algorithm you actually run with the SDK. There is work on getting native plugin support for it, though, so it can be easily run through the app UI as well. Um, then again, add targeting. So as you train and evaluate models, evaluate failure modes based off core model metrics, class confusion, and then update your next batch with additional samples to label that you can again label in the app natively with manual annotation in app or with auto labeling if you are a 51 enterprise customer. Again, approach that 30-70 balance flow. And then again, QA every iteration. Make sure you maintain that kind of golden data set of what you know are 100% correct samples to catch any type of latent drift over. Compare with again, enforce a common schema as well. So again, annotators aren't able to kind of go rogue with the types of labels they are producing. And again, if you notice what I was showing within the in-app annotation, you saw that you can enforce, radio buttons and kind of drop-down selection to make it easier on your annotators. All right. So where to go from here? There's a couple useful resources that will be helpful. Number one is the conceptual flow of this entire talk was based off of um, this tutorial. The link is right here. For convenience, I also included a QR code if you're interested. And then if you want just more general kind of conceptual details about the way we've incorporated annotation into the platform, whether you're new to 51 or you're an existing 51 user, this is a new feature in 51. 51 at its core was a data curation engine for most of its existence. It still is. It's still our bread and butter, and our we posit that that's the best way to get better models is to start with really really good data curation. Annotation is meant to only like provide an engine to that, right? To make the flow tighter, more iterative, and make it easier to add, edit, and apply labels to your data set. So again, this blog post goes into more detail as well if you would like to learn more. With that being said, I want to leave the last couple minutes here for any additional questions that folks may have. I saw, I think Joseph, you had your hand raised. You're free to answer. You're free to ask a question if you still have one, either here or in the Q&A, whatever you feel most comfortable with. Happy to field any other questions as well. Actually, I don't know if folks might be in listen-only mode on the call. So if you're trying to talk and you're muted, you might need to use the Q&A or chat version. I'm also looking back through the chat as well. Yes, statistics on, I see some. Okay, some note takers. I think I answered most of these. Awesome. Another really good resource, just in general, to learn more. Again, if you go to voxel51.com/annotation, that's kind of a landing page for you to get more context on how we've included annotation in the platform. For just getting started, your best friend is going to be docs.voxel51.com. That is going to be your best friend for installing 51, getting started with both the open source and enterprise versions of the software. There is a whole host you'll notice, getting started guides, industry specific guides, tutorials. They're all are in self-contained notebooks. So if you kind of want to, download, run them yourself, look at the GitHub source. Again, this is all meant to be very contained. They almost always start with installing 51 from scratch if you haven't yet. So it's again meant to be easy for you to get going. Yeah. So couple good questions about embeddings. So you'll notice when you look in the 51 methods that the model you use for computing embeddings is toggleable. So here is compute. Hold on, compute visualization. Let's see, torch vision. For some reason, I might be missing where the method is here. But literally, the method, if you look at the method, it's called compute underscore embeddings. And then you would compute the visualization based off those embeddings. You can pass in whatever model you choose. It is not fixed in 51. 51 is extremely open and integratable with respect to that. So you are not tied into particular into any particular architecture. Next question: How to annotate multimodal data consisting of 3D molecular data and tissue pictures. So, um, the 3D annotation, I think for the most part should support that. It's going to depend on exactly what your modality looks like. So again, we support classification and detection for both 2D and 3D data, including 3D point clouds. So when you are annotating, say, molecular data, again, it would depend on exactly your workflow. There could be some classification involved. But again, 3D cuboids are supported as well. Um, if you look at the data set zoo, there might be some healthcare related data sets that you can look through. We also have full Hugging Face integration. So Joseph, my recommendation is um, see if you can kind of parse through the zoo, look for maybe some healthcare related data sets. They're very easy to load if it's on Hugging Face as well. And you can kind of take a look and see if there's any that kind of map with your needs and what it would look like within the annotation feature. Okay, can I use my own embedding model for semantic search? Where will the model be hosted for creating a feature vector from the search term? So there's a couple approaches for that. So when you use 51 for any type of searchability, computing uniqueness, computing what we call mistakenness on the data set, for any of those that are based off embeddings models, the flow is you compute embeddings, you literally pass in the model, which in local 51 would be hosted locally and would need to run on local GPUs. And then from there, you would pass it into the 51 method for what we call similarity search or uniqueness or any of the others. That's an interesting question. Um, I might actually follow up with you on that so I can get a better answer because I might be slightly misinterpreting what you're saying. But yeah, when you're using local 51, the model's almost always going to be hosted locally and it's going to run on local GPUs. But yes, you can use any arbitrary model for computing embeddings. Um, all right. Next question. I'm interested in taking a snapshot for taking the top three relations based on a code base. Um, Not fully understanding your question. Uh, Rasad, sorry if I mispronounced your name. 51 fully supports data set versioning in its enterprise feature. I'm not exactly sure if that's what you're referring to, like snapshotting a data set. That can be done through uh, in 51 Enterprise. There is native in-app support for creating almost basically a Git style version of the data set. You can naturally use other open source tools like DCS for data set versioning, or you can create another kind of hacky way you can do it in open source 51 is by creating separate data set views and then exporting them using an SDK method to create separate data sets as well. I'm not exactly sure if that's what you're asking here, so I apologize. But there are multiple methods in which you can kind of version and snapshot existing views or even entire clones of 51 data sets. All right. All right. So, generally, yeah. So annotation drift. to the last question here is a kind of a broad term that really refers to like differences in like changes in labeling guidelines, which really means changes in schema that causes labels to become less reliable over time because the criteria to label in the first place have changed. So that could take a couple forms. Number one is the actual label names themselves, might change or drift over time. So it was previously just like vehicle, maybe a generic term, maybe over time became car, truck. Maybe what was considered a car or a truck in the annotation guidelines have changed. So now you have a mixed data set of like vehicle, car, truck, but like the model progressively becomes confused because you have multiple. It's basically the language is being changed, and therefore the model's understanding will change. Another way that annotation drift can happen is like the criteria for how you do the labeling changes. So maybe the tightness of a bounding box changes over time. It might go like tighter fit to looser with like more wiggle room. What is considered classific, in edge cases like blurry images or dusk and dawn photos, like what's considered labeling of like night versus day might slightly change over time as different personnel does the labeling. That's really what we mean by annotation drift. And what it really refers to is the model's objective understanding of what is being labeled has changed over time because what is considered objective ground truth has slightly changed over time as well. Now, in some cases, that can actually make the model more robust if it is able to kind of generate a better understanding through multiple kind of edge cases that are labeled in different ways. It can actually become kind of, again, like smart in that case. But on the other side, it can become also confused if there's very clear cases where two labels on very similar objects are shown to be two different things based off changes in annotation guidelines. Yeah. Oren, great question. How would you approach using embeddings when the scene is very busy? Obviously, it can cluster day and night, but what if the differences you are looking for are in the objects and not the scene? Very, very good question. So something we did not directly address in this talk is the idea of patches. So let's see if we actually have it set up here. We might. Do I have a patch view here? I don't quite have a patch view. There's a method you can run called toPatches in FiftyOne that notice each of these samples have multiple boxes in them. What the patches view does is it creates one patch per object. So for example, like a lot of these scenes might have like a dozen different labels on them. What patch views do is they allow you to create um, a sample for every label. And then when you compute embeddings based off of that, the embeddings become more granular on a per object basis. So when you are looking at a particular embedding, you're saying, okay, that is the sample that specifically has like a car in it. It has other things as well, but there's different samples for those other things because of the patch view we created. So when you're looking at very busy scenes like that, you can create multiple patch views that you can then visualize the embedding space on. So yes, yeah, great. You're correct. Yeah. So a good starting point is you would use a foundation model to create some initial like bounding boxes, and then you can create patch views of those bounding boxes, and that does a mapping of one sample per object within the sample grid. And then the embedding space, if you then run embeddings on that particular view after you do the patch conversion, it'll illustrate that space as well. Great question. All right. Any other questions? All right. Well, again, we are at time. Thank you so much for your attendance and participation. Again, we will follow up with some of the resources that I mentioned at both the beginning and the end. Highly recommend pip install FiftyOne. Give human annotation a spin. You can learn more about it in the resources I mentioned. But otherwise, enjoy the rest of your Wednesday. Thanks so much, everyone.